my dear students, how are you? I hope you are all doing fine. Today you are going to make a quick revision on chapter 11 section 4 wave interactions. Okay, so let's see the first question. I hope you have studied it well. Choose the correct answer. Number 1. When two transverse waves traveling through a medium meet and exactly coincide, the resulting displacement of the medium is the same of the displacements of each one, is 0, is always greater than the displacement of either wave alone, or is always destructive. Let's see. When two transverse waves coincide or meeting, the resulting displacement, as we have said before, equal the sum of the displacements of each one. The sum of displacements of each one. Okay? Number 2. When two waves having displacements in the opposite directions, okay, meet. So what occurs? Complete cancellation, no interference, constructive interference, or destructive interference. So about interference, of course interference occurs, but if it is the same direction, the two displacement in the same direction, it will be constructive. If it is in the opposite direction, as we have said before, opposite direction, so it will be destructive interference. Number 3, two waves meet and interfere constructively. Which one of the following factors increases? Which one of the following factors increases? Period, amplitude, frequency, or wavelength. So again, if two waves meet and interferes constructively, which one of the following factors increases? Of course, the number of waves or the number of cycles. So it will be frequency. Frequency. The frequency increases when two waves constructively meet. Not the amplitude or the wavelength, it has no relation, but the frequency, yes. The number of waves or the number of vibrations. Number 4. The opposite diagram represents two pulse waves moving towards each other through a medium. Okay, here is a pulse wave and here is another one. Okay, two pulses are moving towards each other through a medium. So now the question is, the two waves will exactly coincide when they reach point A. When they reach point A, they meet here. So in this point, at point A, the amplitude of the combined waves will be twice that of either wave alone, the same as either wave alone, half that of either wave alone, or 0. Here, I mean here, the displacement here at this point, point A, the displacement equal 0, of course. No displacement here. So the amplitude equal 0. Since there is no displacement here, so the amplitude equal 0. Because the amplitude means the maximum displacement away from the equilibrium position. But actually here is the equilibrium position. So there is no maximum displacement at this area, at point E. So simply the amplitude here equal 0. Number 5. When a wave on a rope strikes a free boundary, the wave is, take care, a free boundary. We have two boundaries, free or and fixed. But the reflection at a free boundary, the wave is reflected and inverted, not reflected, reflected but not inverted, or absorbed. When it comes to free boundary, of course it's only reflected but not inverted. But if it is fixed boundary, it will be reflected and inverted. But since the boundary here is free, so the wave will be reflected and not inverted. Number 6. A wave pattern on a stretched string. A wave pattern on a stretched string appears to be stationary. So the wave pattern is an example of longitudinal wave, non-periodic wave, pulse wave, or a standing wave. We have said before that this kind of wave is called standing wave. So it will be an example of standing wave. Number 7. In a standing wave on a vibrating string, a point that appears to remain stationary. Stationary means fixed, constant, doesn't move. Which point doesn't move or stationary in the standing wave? Antinode, Point of constructive interference, node or rarefaction? Which point is fixed, doesn't move? Of course node, yes, node. Number 8, the opposite diagram represents a certain standing wave on a vibrating string. Here is a standing wave, okay? Now the question is, this standing wave has 4 nodes and 3 antinodes, 2 nodes and 3 antinodes, 3 nodes and 4 antinodes, or 3 nodes and 2 antinodes. So let's count together. Where is the node and where is the antinode? Here is the node, this point, the stationary point, as we have said since a while. The stationary point or the fixed point is called node. And this maximum point, the highest point at the largest amplitude, is called antinode. So in this figure or in this standing wave, how many nodes and how many antinodes? Nodes, let's count. 1, 2, 3, 4. So 4, we have 4 nodes, and about the antinodes, 1, 2, 3. So we have 4 nodes and 3 antinodes. It will be the first choice. Number 9. Standing waves are produced by periodic waves of any amplitude and wavelength traveling in the same direction, any amplitude and wavelength traveling in the same direction, or the same amplitude and wavelength traveling in the same direction, or any amplitude and wavelength traveling in opposite directions, or the same frequency, amplitude and wavelength traveling in the opposite directions. Let's remember together, in the standing wave, the 2 waves are of the same any amplitude and wavelength in the same direction? Of course not. Same amplitude and wavelength, yes, that's right. Same amplitude and wavelength, but in the opposite direction, not in the same direction. So it will be wrong. Any amplitude, no, not any amplitude. In the opposite direction, yes, but not any amplitude. It should be the same frequency, amplitude, and wavelength traveling in opposite direction. So this is the correct definition for the standing wave. So it will be D. The same frequency, amplitude, and wavelength, but traveling in the opposite direction. So here is a standing wave. Now, let's see another exercise. Answer the following questions. Number 1. 2 waves traveling in the same medium. 2 waves are traveling in the same medium are approaching each other. What determines whether constructive or destructive interference occurs when the waves meet and coincide? Again, 2 waves traveling in the same medium are approaching each other. What determines whether they are constructive or destructive? How can we know that? Yes, if the two displacements are of the same direction, like from the equilibrium point or from the equilibrium position, so it will be constructive. But if the displacements are in the opposite direction, so it will be destructive interference. Yes, as we have said before, the difference between constructive and destructive interference. So yes, if the displacements are in the same direction, both, which means both are crests or both are troughs, so it will be constructive interference. But if the displacements are in opposite direction, it means one is crest and the other is trough, opposite direction, so it will be destructive interference. Okay? So it depends on the direction of the displacement. If they are the same direction, it will be constructive. If it is in the opposite direction, it will be destructive. Question 2. A student attaches one end of a rope to a pole and then sends a pulse wave from the opposite end of the rope. Under what conditions will the wave be inverted when it reaches the pole and is reflected? At which condition? Now, if I want the wave to be reflected and inverted, so the boundary should be fixed or free. We have said before the difference between the free boundary and fixed boundary. If it is free boundary, the wave will be only reflected but not inverted. But here, what is the condition for the wave to be inverted when it is reflected or after reflection? So the boundary should be fixed. Yes, the boundary must be fixed, means the rope must be firmly attached to the rope, unable to the pole, unable to slide up and down. Okay, so here is the condition for the wave to be inverted after reflection. I hope you have understand this revision and try to study this section very well and these exercises very well. Okay, now we have finished chapter 11, and see you in our next meeting. Bye bye.